Warm greetings and wishes to everyone. Today I am going to talk about the Maxwell Reciprocal Theorem. So that will be conducted in the strength of material laboratory. So that is one of the experiment for the verification of Maxwell theorem. The case of Maxwell theorem, either you can take the cantilever beam or simply supported beam to explain the Maxwell's theorem. I am going to talk about the simply supported beam. Now the simply supported beam is a beam supported at the ends. For example, this is the pen is a simply supported beam. I am having the support at left end and the support at the right end. So here you mark the 2 points. For example, I am marking, so from the left end the 1/3 and from the right end 1/3. For example, this is 12 centimeter, means the 1/3 of 12 is 4 centimeter here, another 4 centimeter from here. The point from the left end is A and the point from the right end is B. So in the case of simply supported beam, I am explaining the Maxwell theorem. The point A and point B, which is either 4 centimeter from the left and right end support. Now I am placing the load at this point A. At this the point A, right? I am placing the load by means of say 2 kgf. Then what is the deflection at B? Using the deflectometer you can able to find the deflection. You have the deflectometer readings into the least count that gives the deflection or the deformation. Then increase the load to say 4 kgf. What is the deflection? Delta 2, you measure it. Then at the point A you increase the load to 6 kgf. So you find the deflection at B, delta 3. So like that you can go on adding, and where we are getting so 10 to 15 readings at A and B for the loading and the deflection position. Then you draw a graph between the load and the deflection, right? At the point you will get in the y-axis as the load and the deflection in the y-axis. So it will be a linear one. So loading, and similarly you unload the conditions, say 16 kgf, then you find the deflection, then 14 kgf, find the deflection until it reaches 2 kgf and 0 kgf, what are the corresponding reading. Then after that you interchange the loading position to B and the deflection position at A. So once you are loading here 2 kgf for the incremental load, what is the deflection at B? Delta 1. Then you increase to 4 kgf. What is the deflection at B? For delta 2. You load up to 6 kgf. What is the deflection at A? Delta 3. So like that, some 10 to 15 readings you can take. Now you also draw the graph between the x-axis and y-axis. X-axis deflection and y-axis as the load. So it will be a linear one. And you put the decreasing load from 16, 14, 12, 10 up to 0. What is the corresponding deflection? Delta 15, delta 14, delta 13 up to delta 0 point. So in both cases, if you are loading a beam, for example, you have taken a simply supported beam, loading at point A and finding the deflection corresponding increment of load and decrement of load will be equal to the loading at B, and we are measuring the deflection, corresponding deflection at A due to the incremental of load and decrement of load. In both cases the graph will be the same. What will be the load you have taken, the deflection at this point, what will be the corresponding load at B, and what is the deflection at B? It will be equal, almost equal. So that is called as the verification of Maxwell's reciprocal theorem. The author has invented this experiment. That's why His name is given as Maxwell Reciprocal Theorem. So Maxwell Reciprocal Theorem states that for a given beam in a loading condition at A and measuring the deflection at B will be given the same result as if we are interchanging the loading position at B and the deflection at position A. So this remains constant. That means the slope of load versus deflection curve in both condition loading and measuring the deflection at A and B, and similarly loading at B and measuring the deflection at A will be the same. So that is called as Maxwell reciprocal theorem. So this is the explanation about the Maxwell reciprocal theorem using by taking the simply supported beam. Similarly, you can prove this Maxwell theorem by using the cantilever beam also. Thank you very much. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.